Hello everyone, today I'm going to be making a Minecraft style inventory system. I'm going to be using Go and Ebitengine for this, but the language and the framework that you choose does not really matter as long as you can put an image on the screen. If you're unfamiliar with Go, the syntax is pretty simple and it's very similar to a language like C, so hopefully there won't be any issues with that. First thing I'm going to do is I'm going to create a new file here, call it inventory.go, and I'm going to put it in the package main. Now before we start writing any code for our inventory system, I have to think about what it actually is. And a Minecraft style inventory system basically just has a grid of cells where a cell can have either no items or some items, and then we can add to that cell, we can remove from that cell, and we can swap what's in our hand with what's in the cell. So as long as we have those few operations implemented, we can consider it a Minecraft style inventory system. We also have to be able to render it, so we have to keep that in mind whenever we are designing our system. Let's actually get started by figuring out what a cell actually is. And for me, a cell is going to be a struct with a couple different fields. It's going to have the item ID, which is essentially just a unique identifier for an item. So think about grass or dirt or a pickaxe. They would all have their own unique integer identifier. We're then going to put the amount, which is going to be an unsigned integer here, and the amount is essentially just how much of that item is in the cell. I made it unsigned because it doesn't really make any sense for there to be a negative amount in a cell. The next thing we're going to do is we're going to actually create the inventory itself, which is just going to be a struct here, and the struct is going to have a couple different fields. The first field is going to be the actual cells themselves. So this is going to be our grid. And I'm going to make this a single flat slice or array in other languages. And the reason is because it's a little bit easier to work with in my opinion, and we can then just draw it as a grid, whenever we're actually working on the UI. The next thing I'm going to add is the hand. And the hand is actually going to be a cell. Now this is kind of weird conceptually to think about, you don't really think about the hand of the player being a cell, but if you really think about it, whenever you pick up an item from your inventory, you're kind of holding it in some sort of like temporary cell. You have the item ID and you have the quantity, but all that information is stored inside of the hand. So it makes sense to actually model our hand as just a cell because it means that we can very easily transfer the data between the cell and the hand. So it actually does work in our favor, even if it's a little bit weird. So let's go ahead and actually start adding some of that functionality to make this an inventory system. And the first thing I'm going to do is I'm going to add the ability to place items. So this is going to be either adding items to the cell or putting the first items in a cell or swapping the items with the items in the hand. So I'm going to create just a function here, and this is going to be a function of the inventory struct like this, and I'm going to just call it like place items here. This will take in the index and it will return a boolean where the false represents that we failed and true represents that we succeeded. The first thing we probably want to do is we want to validate the index, and so we're going to first do a little bounds check on this, and that's just going to be if index is less than 0 or the index is greater than the length of the cells minus 1, then we want to return false because that is not a valid index to work with. The second thing that we want to do is we want to check if we can merge. So basically, what does this mean? We can merge the contents of our hands with the contents in the cell if they have the exact same type. The first thing we probably want to do is grab out that cell that we're targeting here. So I'm just going to say i.cells at index here. And then what we're going to do is we're going to first check if cell.itemid equals i.hand.itemid. If it does, then we can actually merge them. So what we could do here is we could just say cell.amount plus equals i.hand.amount here. When we do that, we have to remember to actually reset our hand to being empty. So we can say i.hand.amount equals 0, and then we have to set it to empty. Now, in order to actually quantify like what empty is, we have to have some sort of unique identifier for an empty cell. So I'm just going to create a little constant up here that says an empty cell is going to be denoted by -1. Then inside of our code, we can just say that i.hand.itemid equals the empty cell. And this is sort of our generic operation for putting all of the items in our hand into a cell. The next thing we want to do is we want to check if the cell is empty. So we can just say like if cell.itemid equals an empty cell, all we have to do is just empty out our hand and give all of that data to the cell. Cell.itemid equals i.hand.itemid, and then i.hand.itemid equals empty cell, and then cell.amount equals i.hand.amount, and then i.hand.amount equals 0. Oh, and I forgot, these should both return true after these cases are covered. So return true like that. And then the final case is going to be they don't match and cell isn't empty, so swap. And this is going to be the only possible case, so we don't have to have an explicit check for this, because if we pass the first two cases, then we know that they are different cells and we have to swap them. So what we can do here is we can first store a temporary variable for our cell's ID, and then we can say that the cell's ID is equal to the hands ID here. And then we can say that the hands ID is equal to the cell's original ID by doing this temp here. And then we have to do that again for the quantities here. So, I guess I'll just do temp amount like this. And this is going to be equal to the cell's amount. And then we'll just say cell's amount is equal to the hands amount. And then the hands amount is equal to the cell's original amount. And then we can just always return true at this point here. And so that's a pretty simple implementation of placing an item in a slot. Let's actually make a couple little debug tools that we can use to test to see if this actually works. So I'm going to create a method here, and this is just going to be a method of the inventory here. And this is going to be a print inventory function. And all this will do is just print out the inventory. So we'll just say for underscore cell : equals range I.cells, and then we're going to print out our cell here. So I'll do format.print printf here, and this will just be a cell, and the first item in the cell is going to be the ID, and then the second is going to be the amount. And we'll just print a new line character there. So I'll do cell, and it needs to be a range here, and then I'm going to do the cell's item ID and then the cell's amount like this. And why don't we just go into our main here, which is where our entry point is. And instead of actually starting up a game, I'm just going to run the inventory in headless mode, which kind of just means like no UI and that sort of stuff. So I'm going to create an inventory here. So we're kind of running our little dummy application here, and let's see what the inventory actually looks like after we run it. So go run dot, and let's see. So we have 27 cells here, which is quite a few cells, but as you can see, we were just able to completely place the items of our cell into cell 1 and cell 2, so we at least know placing in an empty slot works out. Let's see if the other options work by actually placing the item in the same slot. So I ran it again, and as you can see, there's only our items of type 2 and a quantity of 30, and our hand has the other piece of data. So let's actually make sure that that is happening by, at the very end of our print inventory here, we can print out the hand and dot amounts like that. So yes, as you can see, our hand has the original item that we placed in slot 1, and it has a quantity of 10. So it looks like the hand case works. And there's just one more that we should test before we move on, which is merging them. So let's make this of type 1. And what we should see is that we now have a quantity of 40 of items of type 1 in slot at index 1. So if we run this, so as you can see, our hand now is blank with nothing in it. I'm also realizing that it might be just a little bit easier to define an empty cell as 0 so that all of these are initialized default as empty. So I'm going to quickly go over to the inventory here, and I'm going to change empty cell to 0 just to make it a little bit easier on us. If you didn't do that, whenever you initialize the inventory, you'd have to loop over all the cells and set all of their item IDs to -1 to make them empty. But that's just skipping a step, so I'm being lazy. Okay, so great. Now we have a little bit of default functionality. Let's see if we can actually write a little UI for this so that we can get a little bit more interactive with our system here. So I'm just going to create a new function here, and this is where it gets a little bit more game framework specific, but it shouldn't be too different if you're using something like Raylib or SDL or something like that. So mine's going to take in the screen, which is the target to render to. So Ebitengine.image here. And what we want to do here is we first want to define a couple things before we actually do the rendering. So first thing we're going to do is we're going to do our row size here, which is going to be equal to 9 cells per row. And then what we're going to do is we're going to define cell size here, which is going to be equal to, I don't know, like 32. Why not? Let's also do some sort of like gap size here, which I'm going to set equal to 2, and that should be good to go here. So now what we can do is we can just render a very primitive UI by just looping over the cells and then calculating their X and the Y position based on the index of that cell. So I'll say for I cell : equals range, and then I'll do I.cells here. And then what we want to do is we want to grab the grid position in X and Y coordinates from the index. And the way we can do that is a very common pattern in game development, because this is a very common thing to do. We can grab the grid X by calculating the index, which is then modulus divided by the row size here. What this will give us is the remainder by dividing the index by the row size, which is just whatever isn't evenly divisible by this amount. So that'll give us the X, and then for the Y, it's just the opposite. So we just do I divided by row size, and that will give us a nice clean integer value, which will give us our position in the row. Those aren't the actual positions that we need to draw it. The actual position that we need to draw it, we can define as our pixel X and pixel Y, which we can define as just the grid X multiplied by cell size and the gap size here. And same thing for the pixel Y as well. So now what we can do is just for every cell, we can just draw a rectangle in the Ebitengine world. We can do that by using the vector package here. So I'm going to do vector, and I'm going to do draw filled rect, which takes in a bunch of arguments here. The first one being the destination, the second one being the X, which is going to be our pixel X here. The third one being the pixel Y, and then the width, which is going to be our cell size. The height, which is also going to be our cell size, the color, which I'm going to define at, so just like a darkish gray. And then for the anti-aliasing, I'll put true, and that should be the entire argument there. Now for now, we're not using the cell, so I'm just going to underscore that, but we will be using that in the future. For now, we're just kind of looking at, is the layout going to look okay? So I'm going to go back to main here, and the first thing I'm going to do is fill our screen with some color, so color.rgba. And now back inside of our main function, instead of just testing out our inventory like this, we'll just get rid of that and then actually run our Ebitengine application or whatever framework that you are using. But now our game needs to keep track of an inventory. So inside of our game, I'm going to create an inventory item here like this. And so now I'm just going to assign our inventory like so, which is going to be equal to a new inventory where the cells are going to be equal to a new list of cells of size 27. Then inside of our new game, after I clear the screen, I'm going to do g.inventory.draw and pass in the screen like that. Let's see if we can actually see these cells in action. So it looks like our cells are drawn on the screen. Now they are right up against the edge, which doesn't look too appealing, and they're also a little bit small, so I think I'm going to change a couple things here. The first thing I'm going to do is I'm going to change the cell size to like 64. I wasn't sure how big they would be on screen. And then I'm also going to add just sort of like an offset X, which I'm going to set to like some arbitrary number of 200. And then the offset Y, which is going to be the same thing. And now whenever we compute the pixel Y, just add that offset X and offset Y to the equation, and we should be good to go there. Okay, so this isn't like perfectly centered or anything like that, but it'll work for this initial dummy testing here. And so this is basically our inventory. It's just going to be a bunch of different items here. But now it would be pretty nice if each slot displayed a picture corresponding to the item in that slot. Now, of course, in order to actually do that, we need to have a picture to view. And I have some programmer art of a little, 2D Minecraft clone that I was working on that I'm going to be using for this video. And we're going to just be corresponding the item ID to the location of these blocks in this tile set. So for example, index 1 will be this grass, then 2 stone, then 3 leaves, then 4 chest, etc., as we move along this. So let's actually go ahead and work with that here. So inside of my game struct, I'm going to store my image. So it's just going to be my Atlas image is going to be an Ebitengine image here. And then inside of new game, we'll just do image underscore error colon equals Ebitengine. I think it's Ebitengine util. Yeah, Ebitengine util new image from file. And this is going to be assets.atlas.png. And then if error does not equal nil, we just want to log.fatal because, if we aren't able to load in our image, we can't run this game. So it makes sense to exit the game early there. Then we want to assign our Atlas image to this image we just loaded in. And now inside of our inventory, we should take in that Atlas and just draw based on that. So we'll just take in our Atlas here, our ebitengine.image, and make sure that whenever we are drawing it here, we are providing that image. And then what we need to do here is after we draw the cell itself, we need to draw the item if the slot is not empty. So the first thing to do is to actually check if the slot is filled. So we need to go back here and put that comma cell. We need to put that comma cell here. And then after we draw our fill direct, we can say if cell.itemID does not equal an empty cell. Then what we need to do is we actually need to grab the source rectangle of the part of the image that we want to draw. This is the same process that we use in frameworks like Raylib and SDL3 and Love2D. So it's a very similar process for all of these. We just want to basically create a rectangle that is used to crop out a portion of the target tile set here. So let's go ahead and use that information and generate a tile set. Now, in order to do that, we can actually get our ID first. So we're going to do cell.itemID, and we actually want to subtract 1 by this. And the reason is because our first index is going to be index 1, but in order to get the top left, everything should be shifted over by 1 so that the first one is index 0. Basically, think programmer style, first index needs to be in terms of 0 here. Next thing we need to do is we need to actually get that source rectangle here. And for that, I'm going to be using the rectangle struct that comes built in with the image package in Go. So image.rect here, this takes in the X and the Y of the top left, and then the X and the Y of the bottom left, which is not to be confused with the X and the Y and the width and the height. It is different. So in order to compute these, we actually use an extremely similar approach to how we did it over here, where we converted the cell's index to the X and the Y. So the first thing that we need to do here is we need to figure out how many of those items are on each row of our image. And so that's going to be our number of items per row here, which is just going to be equal to the atlas.bounds.dx, which think of dx as just the width of our image. And then we're going to just divide this by our tile size. Now you have to just know the tile size of your tile set. And I know that mine's 8 because I made it. So it's just 8.0 here. From that, we're able to get the grid X and the grid Y of the image on our cell. So we can actually grab those here. I'll do gx equals the ID modulus divided by the number of items per row. And then gy equals the ID divided by the number of items per row. Whenever we're actually constructing our image rect, we'll do gx multiplied by our tile size and gy multiplied by our tile size. And then for the bottom right, we'll do gx plus 1 times our tile size, and then gy plus 1 times our tile size to sort of capture the bottom right. Finally, we can just draw our image. In Ebitengine, that is just screen.drawImage here, takes in the image we want to draw, which is our atlas that we passed in, takes in the Ebitengine draw image options, which we will just create here default just to start with. So options : equals ebiten.drawImage options like this, and just pass in that here. And to actually use this source rectangle, we will do .subimage, which takes in an image.rectangle, and then we'll pass in that srect that we just created. And unfortunately, subimage returns just a generic image interface, so we have to typecast this to in ebiten.image at the end there. That's a bit more like framework specific things, not really functionality based, but it is a little bit complex, so keep that in mind here. Now, as far as the position of each of our images, we can just do ops.geom.translate, and we can use that grid X and grid Y that we got from drawing our cells each here. That was quite a bit of information, but this is how we are drawing things. So let's do go run dot, and let's see what this looks like. Oh, right, and we also have an empty inventory, which is, not exactly what we want to do here. So let's go to our main.go, and whenever we're making our new game, instead of just making our inventory inline like this, I'm going to say inventory equals our new inventory like this, and then just assign it like this, so inventory like that. And so instead of just directly creating our inventory inside of the game initialization, we're going to create it up here, and then we can place some items. So I will do inventory.hand.itemID equals 1, and I will do the amount equals 10, and then I will do inventory.PlaceItems at index 1 here, and then I'm going to just copy this here, make this, index 2, and then I'm going to place that at like number 12 or something. So now we kind of like have seeded our inventory with some initial items. Let's see what happens here. Oh, and right. So we weren't supposed to use the grid X and grid Y. They were supposed to be the actual pixel X and pixel Y. So let's go back to our inventory here. And instead of translating it by the grid X and grid Y, let's translate it by the pixel X and the pixel Y. Now they are actually in their correct spots, but they are very small. In order to fix that, we can actually scale them. So I'll say ops.geom.scale, and I'm going to just put in 8.0 and 8.0 here, because if the tile size is 8.0 and the cell size is 64, then we want to scale it up to be the size of the cell. So we need to do 8 times 8. So now we should see that yes, our tiles are in their correct spots. So amazing stuff. So the next thing I'm going to add is I'm going to add an update method for our inventory. And think of this kind of as like the runtime for our inventory. Like it's going to handle, handling mouse clicks and all those sort of things like that. And so what we can do with this is we can figure out if we're clicking, where are we clicking, and what to do with that cell. So why don't we handle that? First, we will just check if the mouse has been clicked, which we can just use the input util dot is mouse button just pressed, and then we can do Ebitengine dot mouse button 0, which is our left mouse click here. And then we'll just say like if mouse clicked, then we want to check if clicked cell and then do something about it, right? So in order to check if these cells are clicked, it would be a lot easier to do if we were able to pre-compute the hitboxes of all of our cells. Now that sounds like complex, but it's really not that complex. Let's just add a new field to our cell that I'm gonna call the hitbox. And the hitbox is just going to be a rectangle like this. And what we're going to do now is, instead of directly just creating an inventory with struct initialization syntax, we're going to create a constructor, or what Go has instead of constructors, for creating our inventory through an actual controlled environment here. And so the first thing we want to do is we want to create our cells here, which is just going to be a slice of cells and of length 27 here. And then what we want to do is we want to actually compute their rect value here. Now the rect value can be calculated very similarly to how we did it down here when we were drawing. So I'm going to create a little helper function here that's just going to be our get hitbox. This is going to be given the index of the cell in the grid, and then it's going to be given an offset X and an offset Y, which are going to be the rendering offset of the whole thing, which we just arbitrarily put as 200 here, but we'll change that hopefully soon. And this is just going to return an image rectangle here. So the first thing we need to do is we need to account for that offset X and that offset Y. So what I'm going to do is I'm going to pull all of these values here. So the offset X, offset Y, gap size, cell size, and row size. I'm going to pull those out, and I'm going to make all of these constants. So we're going to make a constant block, and I'm going to put this here, and then I'm just going to get rid of all these colons, so that all works out like this. And now they are all constant values here. Now we're able to use them not only in the draw method, but also up here, which is going to be very, very useful. So the first objective in actually calculating this hitbox is getting the grid X and grid Y position of this, which again, we can just get from what we had earlier here, which is going to be this. So let's just go back and take that code and paste it. It's exactly what we just did earlier. So, we're stealing our own code here, and just change that I to index. And then we should have our pixel X and our pixel Y here. And then all we have to do from that is just return our image.rect here, which takes in the pixel X, the pixel Y, and then for the bottom right coordinate, which is the X1 and Y1, we need to do the pixel X plus the cell size, and then the pixel Y plus the cell size here. Okay, great. So that was wonderful. Now we are able to compute the hitbox based on just the cell with an index here. I also noticed that, since we're using globals for offset X and offset Y, we don't need to provide them here. We can just take them from those globals there. So then what we can do is we can just do for I : equals range cells, and then we can say cells at I dot hitbox equals get hitbox and pass in that index value. Finally, we can just return our inventory here. So return the inventory with the cells equal to those new cells, And then the hand is just equal to a default cell. What's actually great about this is instead of having to do all of this computation here, we can just comment that out and we can use our cell. We can do cell.hitbox.min.x here, and we can do cell.hitbox.min.y, and then we can do cell.hitbox.dx and dy here, which are functions. Now we don't need our index at all here, but we have, greatly reduced the amount of code that we have to work with there. Now that does mean that we can't use the pixel X and the pixel Y whenever we're drawing our image, but we can instead just use the cell.hitbox.min.x and the cell.hitbox.min.y here. So I did go a little bit fast there, but basically instead of, recomputing the rectangle to draw for our grid every single frame, we are now pre-computing them, which will make it really, really easy whenever we want to check for collisions. Now what we can do is just run this and make sure that everything looks like normal, and it most certainly does not, so that's not very good. So the issue is due to the way that Go handles things when we're looping. When we're looping here, we're actually copying the values, and the reason is because I was creating a slice of actual cells by values, but it could be a little bit easier to work with if we just make these pointers to cells. So I'm going to make these pointers here, not a huge performance hit because it's a small amount of cells, and so it shouldn't really matter too much there. But this also means that instead of just directly assigning the hitbox, we actually have to create the entire cell. So we'll say cells.I equals a new cell type here where the hitbox is equal to get hitbox at I, and we need to make that a reference. And that also changes a couple things here. So instead of grabbing the reference of the cell like this, we actually just get rid of that reference. And then inside of main, instead of directly making our inventory like this, we would make it with the new inventory here, and then remove the reference here. Now if we run it, you'll see that now we are back to normal, but what's great is now we are just drawing these with the pre-computed recs. And so now what we want to do is we want to check if we click the mouse and the mouse has collided with any of the cells. And so the first thing to do is to actually get the position of the mouse. So I'm going to do mouse X, mouse Y, :equals range, Ebitengine dot, I think it's mouse position, or it might be cursor position. And then I'm going to convert this to a point. So I'm going to call this my mouse point here. This is going to be equal to a new image point. And the reason is because it gives us a nice, convenient way to check collisions. So then we just want to loop over all of the cells and check if we collided with any of them, which is not a big deal because we only have 27 of those. So let's just go ahead and do for index cell : equals range I.cells here. And then we will say if mouse p.in, and in takes in a rectangle that we are checking if we are inside of. So we'll do cell.hitbox here. And if the mouse is inside of the cell and we have clicked, then we probably want to do something with that. So we will do I.PlaceItems here. And this takes in the index, which is just that index of the cell that we are currently looping over. So there you go. And I guess that the do something should be up here now. So there we go. That is basically the simple functionality of this whole thing. So let's go over to our main.go, and inside of our update function, we'll just call g.inventory.update here, and that should work perfectly fine. So now we'll do go run dot, and let's see what happens. So I'm going to click on this stone, and what we should see is the stone disappears, and our hand now has that stone. So I'll click on it, and the stone disappears, and I click somewhere else, and I have now placed the stone in a different spot. This is pretty cool. This is kind of like your hello inventory. It's pretty fun to mess around, and especially because, I got this first try recording, so that's pretty cool stuff. So now we can kind of just like mess around and just move our things around and have a good time. I think the next step to this is actually going to be rendering the amounts of these things. Now, luckily, Ebitengine provides a relatively simple way to draw text to the screen, but it's not like perfect looking. It's kind of like a debug text type of thing. I'm going to stick with that for now because I don't really care how it looks too much. So whenever we are drawing our cell here, if the cell is not empty, then we want to draw the quantity. So for me, that's going to be Ebitengine dot, and then it's going to be, I think it's debug print at, and this takes in the destination image we want to draw to. So we want to draw to the screen, takes in the string, which I'm going to do format.sprintf here, which will take in a quantity. And then for that, it's just going to be the cell.amount. And then I just need the X and the Y position, which are just going to be the cell hitbox.min.x and the cell.hitbox.min.y like that. This should hopefully just render the amounts automatically. So let's go ahead and see if that works. So yeah, we have 10 here. It's a little bit small, so I hopefully you can at least see the shape of it. But yeah, we're clicking and it looks like we are seeing our items here. Oh yeah, and then also we should probably test out swapping hands, so we can just click and it looks like we are swapping hands perfectly fine. I guess the next step of this is to actually show what item we have inside of our hand, and that's actually not too hard. We can just go inside of our inventory, and I think I'm going to pull this out into a separate function. I've been writing some pretty monolithic functions in this video, so let's actually write something that's let's actually make it a little bit more modularized here and make a new method called draw hand here. And hand is just going to take in the target that we want to draw to, which is our screen. So ebiteng.image here. We will then just check if i.hand.itemid does not equal the empty cell, then we want to actually do something. If it's empty, we don't need to draw anything. If it's not, then we can just simply draw it here by doing screen.drawImage, and this will take in our image again, which I'm just going to go ahead and copy that source rect code that we had from before here. And so I'm just going to copy all of this code from where we were drawing our stuff before, paste that up here, and instead of doing cell.itemid, I'm going to do i.hands.itemid, and then instead of, oh, and we do need to provide in the image atlas, which is basically, you know, the texture atlas that we were using for everything else. And then down here, whenever we are drawing our image, we will use that atlas.subimage, and then pass in that srect that we calculated. And then we need to type assert that to an Ebiteng image, and then we need to pass in our options. And instead of doing cell.hitbox.min.x, we do i.hands.hitbox.min.x and i.hand.hitbox.min.y. So hopefully that wasn't moving too fast. I essentially just copied over the code from the original draw method and just changed it around to work with a hand. If I was a good programmer, I would pull that out into a function that didn't care if it was a hand or a cell, but I'm not a good programmer, so I'm just going to keep the duplicate code and I'm going to go about my life. But let's go ahead and actually see if this works. I actually do have to call the function. So let's go to the end of our draw method here, and let's do i.drawHand and pass in the screen and pass in the atlas like that. Okay, great. So we see nothing, but then we click on an item and we are not seeing the right thing. It is drawing in the top left corner. And the reason is because we are not updating the hand cell whenever we move our mouse. So what I'm going to do is I'm going to pull out this mouse X and mouse Y from the if mouse clicked, and I'm going to simply put it at the top level of our method here. And then I'm going to say i.hand.hitbox equals image.rect here. And this is just going to be our mouse X, our mouse Y, and then our mouse X plus our cell size, and then our mouse Y plus the cell size like this. So now let's see if it actually follows the cursor. So there we go. It looks like the rectangle is following the cursor. It is kind of like hanging down in the bottom here, but we could just change that by doing a little bit of math. So instead of translating it just by the position here, we could also subtract half of the cell size. So we can do minus cell size divided by 2. And then we can do the same thing for the other argument. So minus cell size divided by 2 here. Now if we click, we should see that yes, it is directly in the center and the quantity goes away, but it would be as simple as just drawing the text at that location again. To keep that quantity showing, we'll do ebiteng util.debug print on the screen, and then for the string, we'll do format.sprintf, and then we'll do %d, and then we'll do i.hand.amount, and then for the x, I will do i.hand.hitbox.min.x, and then for the y, it's .min.y here, and that should be good to go. So now if we click on this here, oh, the text does not work because I did not translate it correctly. So again, yes, we do the minus cell size divided by 2 and the minus cell size divided by 2 here. Okay, now, yes, it looks smooth. It looks like we've got some stuff going on here. This is looking like a proper inventory system here. Now, I could basically call this done, but I'm going to add the right-clicking functionality because I feel like that is pretty important for a Minecraft inventory system. So why don't we go to our inventory's update method here, and let's check for the right mouse clicked. So the right mouse clicked, and then we're going to use, I think it's mouse button 2. It might be mouse button 2. So now what we can say is we'll just say like if right mouse button clicked, then again we want to check if clicked cell, and then, you know, do something. So I mean, honestly, we can just take a lot of this code and we can just paste it here. But instead of placing the items, we will do another thing. We will place one item maybe. So let's actually make that function. So we have our place items here. I'm gonna create a new method. So I inventory here. And this is going to be place one item, right? And this will take in the index of the cell and return a Boolean here. So if you think about it, honestly, a lot of this function is going to be very, very similar to the place items. So we could honestly, you know, I'm doing a little bit of bad practice here, but I'm going to do some duplicate code because it's very simple. So I'm just going to copy the contents of place items and place it into the place one items here. So now if we can merge, rather than just adding the entirety of the hands amount, we're just going to add 1. And then we're going to subtract 1 from the hands. Now this does make it a little bit more complex because we have to check if i.hand.amount is less than 1, then we'll say i.hand.itemID equals the empty cell here. Now we have to check if the cell is empty. Now if the cell is empty, we do the exact same thing where we only add 1 to the cell's amount. So we just change this to plus equals 1, and then we subtract from the hands amount, and then we check if the amount is less than 1, if it is set it to an empty cell. If we don't match any of them, then we simply swap, and if we are swapping, then we actually have the exact same functionality. So we don't have to do anything there. So let's go over to our update method here, and let's call that new function we just created. So i.placeOneItem and pass in that index there. Let's try it out. So the first thing I'm gonna do is I'm gonna right click some dead space so it's not working there. But we can click on an item and then we can right click, and oh, that's an issue. Oh, right, I set it to empty cell here, but it shouldn't be set to empty cell. Just remove that part. You shouldn't automatically set it to empty cell if we just remove one item. It should only be if the amount is less than 1. Okay, let's try it out. So we click on an item, we right click, and it decrements, and we can now populate and transfer this data here. So I can click this, transfer them, and as soon as I run out, I now have an empty cell. I can just do this and put some things across all of here. Great stuff. There is actually one issue with the way that we're doing things, and I can show that here. So all of the things that we did work great, right? Right clicking here places an item, that's great. But whenever we right click here, it's actually just swapping the hands, which means that we pick up the entire stack. But what's supposed to happen here is that we actually take half of the stack. We actually have to add an extra case to account for this half stacking sort of thing that goes on with right clicks. And so the way we do that is we say if i.hand.itemID equals the empty cell, because that's the only way that we're able to grab half. Then we want to do a new thing. So we want to just define half as first the half of the amount in the cell. So we're going to do cell.amount divided by 2 here. And then what we want to do is we want to say i.hand.itemID equals cell.itemID. And then we'll say i.hand.amount equals the half, because the only way that we're getting here is if the hand's an empty cell. And then we'll say that the cell.amount minus equals the half. And then finally we'll return true. Okay, let's see if that actually works. So we're on here, we're on a cell, we right click, and now we have 5. And if we right click again, you'll see that we are transferring items back in. So we're able to split things like this and then put items in. So it looks like we have an effective system, except I just found a bug. If I right click a slot with only 1 in it, it will give me a 0 grass here, which actually allows me to just duplicate my grass and give me infinite grass, which is not good. And the reason is because we aren't accounting for the cell's quantity being 1. So we have to do and cell.amount is greater than 1. If it's not greater than 1, then we can simply just ignore it and go back to that base swapping case here. Okay, so let's see if we fix that bug. So I can just click this here, drop 1 there, and let's see, we right click and it looks like we only pick up 1. So pretty good stuff. So it looks like we have a working inventory system here. So I hope this is enough to be considered a Minecraft style inventory system. And just to show you that this inventory system actually works, I have this game that I made like a couple of years ago that uses almost the exact same approach. So let's just go ahead and load in a world here. And if we open up the inventory, I have just a little inventory system where I can grab half and I can place things in. and I can just place one item at a time and all that sort of stuff. It's almost the exact same approach as what we did in this video, so it does actually work for a game. By the way, the source code for this is going to be in the description if you dare to look at it. It is really old when I was actually like first learning Python, so some of it is horrendous, but if you want to look at it, feel free to. So that about concludes the video for today. We have a working inventory system here. If you enjoyed the video, you found it useful, consider liking and subscribing. And if you have any questions, you can leave them in the comments below, or you can consider joining my Discord, where there are a ton of people, software developers, game developers, that would love to help you out. Also consider supporting me on Patreon so I can continue making videos like this. Thank you very much for watching. Have a good day. See ya.